This is a video just going through a couple of the solutions from the worksheet that I gave you on independent and dependent events, and it's the worksheet that says Q2 software up the top left-hand corner. So I'm going to look at question 18 first of all. It's important to note that at the start of this section of questions that we were given the information that the events A and B are independent. So we can definitely work on the assumption that the probability of A times the probability of B equals the probability of A intersection B. Okay, so let's have a look at the information they're giving us in question 18. So in this question, we're told that the probability of A is 7/10, and the probability of A or B is 173/200, and then we want to find the probability of B. Now, the first thing just to note here is that when they say the probability of A or B, they're talking about A union B. And since they're referring to some set notation, it probably wouldn't be a bad idea for us to actually draw a Venn diagram so we can visualize what's going on in this question. So I've drawn my Venn diagram and I've labeled A and B. And notice again, as usual in probability, that I don't call the universal set, I call it S for sample space. Okay, so let's look at what we know. We know that A has a probability of 7/10. That's the whole A set here. I know that A union B is 173/200, but it's really hard for me to fit anything in directly because I don't know what the individual portions of those sets should be. To make life a little bit easier for myself, first of all, I'm going to get everything with a common denominator in the information that I have so far. So I'm going to write the probability of A as 140/200. Okay, so now this whole set A is 140/200, and the whole lot of A and B all together is 173/200. So actually now I know what to fill into this part of the diagram. So that part of the diagram is going to be 33/200. Now what's catching me out filling in the rest of A is that I don't know what to put into the intersection. So I'm going to just fill in x/200. So it's some value over 200. I just don't know what it is. And by doing this, this allows me to write something down for this part of the A set. So I know that the full A set is 140/200. So this part is going to be 140/200, just take away the intersection. And so I can write that as 140 minus x/200. And if I like, I can fill in what's outside of A union B as well, which in this case is 27/200. And that actually won't really be necessary for the calculations in the question, but it's just nice to have it there for a sense of completeness of the Venn diagram. Okay, so to go back and have a look again, I know in this question that A and B are definitely independent. So I know that the probability of A times the probability of B equals to the probability of the intersection. And I have something now that I can write down for each of those regions. So the probability of A, first of all, I know already is 7/10, or if you like, 140/200. I've got something that I can write down now for the probability of B. So I can say the probability of B is 33 plus x/200 by putting these two parts together. And I'm able to say now that the intersection is x/200. So I'm going to take those values and I'm going to fill them into this formula here. So I've got 140/200 times 33 plus x/200 equals x/200. And really now I'm just doing a little bit of algebra to figure out x. So multiplying out on the left-hand side, I'm going to get 4,620 plus 140x over 40,000. And on the right-hand side, it's x/200. It'd be really nice if I didn't have denominators to worry about here, and I can sort that out by simply getting a common denominator. And that can be done by just multiplying the right-hand side by 200 above and below the line of the fraction. So now, since I've got a common denominator, 40,000 here, and 200 by 200 is 40,000 here, I can just work with the numerators. So I now have an equation 4,620 plus 140x equals 200x. Easy peasy to finish this one out. So I'm going to subtract the 140x, which will give me 60x, and then I'll just divide by 60 to get x. And that comes out as 77. So now I know what's in the intersection of my Venn diagram from earlier. And now that I know this intersection, well, it's really easy for me to go and find the probability of B. And don't forget, that was the goal in this question all along. So to find the probability of B, I'm simply going to add together the values in these two regions. And when I do that, I get 110/200, which I can cancel down to be 11/20. And 11/20 is my final solution here. Next, let's have a look at question 22 from further down the sheet. So in this case, we're told the probability of B, the probability of A union B, the probability of B given A, and we want to find the probability of A. So again, a good approach, like last time around, is to draw out a diagram for ourselves. So I've got my Venn diagram. My universal is called S for sample space. I've got my A set and I've got my B set. And again, kind of the problem that I'm encountering here is that I don't know what to put into the intersection. That's really hampering me filling in the diagram overall. So I have to have a look at the information that I have and see what I can glean from it. It's a little bit like question 18, really. So I know that probability of B is 0.45. So this whole set here is 0.45. I just don't know what goes into the individual parts of that set. I do know as well that the A union B is 0.72. So I now know what to put into this portion of the diagram. If this is 0.45 and we've got 0.72 in total, then I must be filling 0.27 in here. Like I said, I don't know what to put into the intersection. I haven't got a value for it. So for the time being, I'm going to call that X. And that's going to free me up then to write in something in the remaining portions of the diagram. I know that B has a probability of 0.45. So this part of the diagram must be 0.45 minus the X from the intersection. And again, if you like, you can fill in what's outside of A and B, but it's not really compulsory, just really for a sense of completeness more than anything else. 0.28 can go in out here. In this question, they didn't really make a statement so much about independent events for A and B, but you can see in the question they're referring to conditional probability. So it's really this conditional probability statement that's going to allow us to work out our solution. And it wouldn't be a bad plan to write down the rule for conditional probability before we proceed. So in this case, I've got the probability of B given A, which would be equal to the probability of B intersection A over the probability of A. And in the question, I have a value for the probability of B given A, which is 0.4. And while I don't have a value for the probability of B intersection A, I have assigned it X in my diagram, so I can fill that into the formula. And I can also write the probability of A in terms of X, because the probability of A is this whole region here. So I'm just going to put the 0.27 and the X together to make 0.27 plus X. So now just, again, a little bit of algebra and manipulation will allow me to work out the value for X. So I'd suggest pausing the video here and seeing, can you manage that yourself? And then play and check and see if you're correct. So I'm going to multiply the 0.4 by the denominator, which is going to give me 0.108 plus 0.4x equals x. Don't forget this x over here is a 1x. And then, just like usual, I'll get the constants on one side, the x terms on the other side, and I'll solve for x. And then I'll divide by 0.6 to get the value for x, which is 0.18. Now it's tempting to stop here. We've got x, we're done. But actually, no, we're not. Because if we look back to the question, they asked us to find the probability of A. And of course, the probability of A is everything in the A set. So it's not just the x, it's the 0.27 as well. So now that I know the x value, I can add it to the 0.27, and that's going to give me the probability of A. So 0.27 plus 0.18 is going to give me a resulting probability of 0.45 for A. And this is the final solution for this question.